Yes, we are.
Good morning, sir.
Welcome to this lecture 3 on the course Synchronous and Special Machines, and we are discussing the topic for the previous two classes, construction features of wound rotor and salient pole machines. Okay, so this is the overview of the lectures 1, 2, and 3. Today's lecture I have scheduled it as lecture 3, and therefore I want to give you all this PPT, right, as lecture 1, 2, 3. Therefore, I have put this as lectures 1, 2, 3. The overview, yesterday we have seen this, and a few things I have added today. Course introduction, course outcomes, intended learning outcomes, types of synchronous machines, definition of alternator, construction features of synchronous machines. All these things we have seen, and in the construction features of synchronous machines, we will be seeing the stationary armature and the damper windings today, and some questions from this lecture, these three lectures 1, 2, and 3, and I have scheduled these to be remember level, and categorized these questions under remember level and understand level, and based on the questions and the magnitude of the question, the question marks, the questions might carry 2 marks or 4 marks or 6 marks or 8 marks, depending on the magnitude of the question. Okay, so these are the stationary armature in the topic 6th number and 7th number we will be discussing today. In the syllabus and all we have seen the course outcomes, the types of synchronous machines, we have seen this on rotor and a salient pole, and basic diagrams, right? And this diagram is important. This is a construction feature, construction diagram. You will have to practice drawing this diagram because you can draw this diagram in your exam. And definition of an alternator, main parts, these two are okay, and construction features, these are the explanations which I want you to write, and along with this diagram you have to draw the diagram. If you are asked to write or explain about the construction of an alternator, all these 4 or 5 slides. And salient pole type, again you will have that is a salient pole machine, and cylindrical rotor pole type, you have this some 3 or 4 slides again, and the main parts of synchronous generator, stator, rotor, and miscellaneous. And stator, there are some important parts of the stator, and the functions also you can see in this, yesterday we have discussed. And the rotor and the diagram, salient pole rotor and diagram, the rotor construction and salient pole rotor diagram, the explanation of this rotor, the different parts of the rotor, salient pole rotor, and non-salient pole rotor or cylindrical rotor, we have some explanation. The diagram of this non-salient pole rotor, a 2-pole machine and a 4-pole machine. Diagram you have to practice, and non-salient pole rotor, a few more points, and the important parts and the functions, and yes, advantages of some stationary armature rotating field alternator. I have discussed this generally in the first class, in the advantages of stationary armature rotating field alternator. What are the advantages of a stationary armature and a rotating field alternator? What is the difference between a DC generator and an AC generator? We know DC generator, rotor rotates and armature rotates and field is stationary. In an AC generator, the reverse happens. That is, the armature is stationary and the field is rotating, and hence, what are the main advantages of these? Alternators are generally high current and high voltage machines, right? And hence, there are some advantages. And what are these advantages when we are going for such a mechanism? The first point here is the current can be drawn without brush contacts, right? Directly, it can be drawn directly from fixed terminals on the stator without the use of brush contacts. Then the insulation of stationary armature winding is easier, right? Insulation is easier. Then again, the number of sliding contacts can be reduced, right? Because the sliding contacts are used for low voltage DC source, right? And armature windings can be constructed more rigidly to prevent deformation due to any mechanical stress, because armature is not rotating here, right? Armature is kept stationary, and only when rotating parts are there, then only deformation might occur, right? Even though proper care is taken during the design, but still there might be some deformation. But since here in this AC generator, armature windings are constructed to be stationary, and hence there will not be any um, deformation. So these are the four advantages of stationary armature, and this can be a 4-mark question. Okay. Now let us see what is a damper winding. Damper winding. What are the advantages? What is the purpose of damper winding? We'll try to see. Right. See, in this diagram, you can see that this is taken from some internet website. Why damper winding is used in synchronous machine is a very important question. And in that, where are you placing these damper windings? Where do you place the damper windings? What is a damper winding, and what is the purpose of a damper winding? Why damper winding? Damper winding indicates it will be used in synchronous machine. Okay, so here in a synchronous machine, we have stator and rotor, and stator winding is there, and we have main field winding, which is also called the rotor winding, right? And in additional to stator and rotor windings, we are having one more winding, which is called the damper winding, which is shown here, the damper winding, right? The black dots on each phase of the rotor pole, right? You can see the damper winding. There is one more original structure of a damper winding. See, we can see the damper bars here. Damper bars is written here, and these are the damper bars. Damper bars. This white color bars, you can see. This is field winding, rotor field winding. Okay. Hence, you can also see in this diagram. This diagram is quite explanatory here, self-explanatory. You can see here, right, the damper winding. They are placed on the face of the rotor poles, right? These are damper windings, the black dots, right? Damper windings. So you can see the stator and all these things. I just try to. So what is the normal electrical circuit? You can see some DC supply is given, right, to the damper winding. Okay, and to the stator winding. Okay, DC supply is given to the normal rotor winding. Okay, and damper windings are completely short-circuited windings at both ends. They are completely short-circuited windings at both ends. You can see this. Right, positive and negative DC supply is given to the rotor winding. Okay, so that is one important thing. Now this can be an important interview question also. What is the purpose of using damper winding in synchronous machine? Okay, the main purpose of using damper winding in synchronous machine is to provide starting torque and eliminate damping or hunting. Yesterday's or day before yesterday's class, I have discussed this damper winding regarding this. Yes, in yesterday's class during the construction of an alternator. But firstly, let us know what is a damper winding. Right, the damper windings are made using copper bars, which are short-circuited at both ends. They act as short-circuit coils, right? As you can see, act as short-circuit coils. This is completely short-circuited. Okay. Probably let me. Yeah, you can see this everywhere. We have the phase of the pole. Right, damper windings are placed in the phase of the rotor poles of the synchronous machine along the pole axis. Right, so this is damper winding, the location of damper winding, and how they are made up of copper bars and short circuited both ends. They are made of copper bars and short circuited both ends. Right, they act as short circuit coils. Now this is what is called as damper winding. What is the main purpose of damper winding? They provide starting torque and eliminate damping or hunting. Now, purpose, this you can write it in, though I have given it in terms of points, you can write it as a paragraph here in your exam. Purpose of using damper winding in synchronous machine. In a presentation or a PPT, it's better always to show it like this in terms of points, so that this is a single part, 2 or 3 purposes only which we will be having for damper winding, but what is happening point wise I wanted to discuss here. That's why I have placed this slide here. Now when the load on an alternator suddenly changes, right, say it increased, then the rotor falls out of synchronous. We know that synchronous speed is designed to be run at synchronous machine is designed to run at synchronous speed. Synchronous speed depends upon the frequency and number of poles. Right, frequency hours is always 50 Hertz. Therefore, the synchronous speed depends on number of poles. Okay, so if it is a 2-pole machine, we know it is 3000 RPM. 4-pole machine, it is 1500 RPM. So when the load on an alternator suddenly changes, let us say it is increased, then the rotor falls out of synchronism. That is, when load increases, obviously the speed reduces. Right? Speed reduces. During this time, rotor rotates at less than synchronous speed. Okay, obviously when speed is falling down, right, during this time, since the rotor rotates at less than synchronous speed, the damper winding comes into picture. It is a short circuit coil, and whenever the relative velocity between the damper winding and the original rotor field, there is a difference between these two, damper winding rotation and the rotor field rotation. That is the EMF caused in the damper winding and the EMF generated in the rotor. If these two are having a difference, right, an EMF will be induced in the damper winding, an additional EMF will be induced in the damper winding when the rotor rotates at less than synchronous speed. So this additional EMF that is developed in the damper winding will create a flux, which will increase the speed of the rotor to catch the synchronous speed. Right? It will increase the speed of the rotor to catch the synchronous speed. అంటే additional EMF ఇచ్చాం అనుకోండి. ఇప్పుడు ఒక 230 volts supply on a single phase అనుకుందాం. 230 volts supply, when it is there, right, it is running at certain speed, let us say 1500 RPM. If it is 220 volts only can be given, then obviously it will be reduced, isn't it? The speed will be reduced. Right, so you have to give that additional 10 volts to reach 230 volts, so that the rotor runs at 1500 RPM. So this damper winding will help us in creating a flux, which in turn will create the EMF, and this EMF will increase the speed of the rotor so that the rotor catches with the synchronous speed. So the damper winding will always try to keep the rotor speed at synchronous speed, right, which will always try to keep the rotor speed at synchronous speed even during sudden load changes in the alternator. In that way, what happens, the hunting can be eliminated in the alternator using damper winding, right. So for smooth running of the alternator, damper windings are used. For smooth running of the alternator, damper windings can be used. So this is what I wanted to explain during this. But Saket, Namrut Sai, do you want to control the presentation? Namrut Sai.
No sir, that is by mistake I checked it.
Okay. So better you concentrate on the lecture, okay? Don't you can do this later on also. Okay, so this is purpose of using damper windings in synchronous machine. Why damper winding is used in synchronous machine? It is to increase, to provide the starting torque and eliminate damping or hunting. What is a damper winding? It is a copper bar which is short circuit at both ends. It acts like a short circuit coil, and it is placed on the face of the rotor poles of the synchronous machine. Okay, so this is the first topic that we have discussed in our the first topic of our syllabus, construction features of wound rotor and salient pole machines, right? And I have segregated this into three lectures, lectures 1, 2, and 3. Okay. So I would like to just dwell upon the number of questions that might arise during this first topic of our syllabus. So I have segregated this or categorized this into two levels, remember level and understand level, because we are still in the initial stages. So I wanted to just dwell only upon remember level and understand cognitive levels. So remember level questions can be like this: define an alternator, recall the types of synchronous machines. uh, I think you'll have these questions. Define an alternator ante, you know what is an alternator. I'll just have a close, give some examples, give some more explanation on this. Initially, I will be trying to take this, and not every class I will discuss like this, because I wanted to start slowly so that you people can me. And define an alternator. Yes, page number 13, we have this. An alternator is defined as a machine which converts mechanical energy to electrical energy in the form of alternating current at a specific voltage and frequency. A specific voltage and frequency. If this term is not there, at a specific voltage and frequency, then alternator definition only half marks can be given if you write in the form of alternating current, right? Or simply if you write it converts mechanical energy into electrical energy, every generator will do the same thing. It need not necessarily be an alternator. If it is converting in the form of alternating current only, you can say that it is an alternator, right? And at a specific voltage and frequency. And alternators are also known as AC generators. And recall the types of synchronous machines. What are the types of synchronous machines we have? Yeah, we have this wound rotor, round rotor. The different names for wound rotor is wound, round, non-salient pole, and cylindrical rotor. Right, and that is one type of synchronous machine, and the other is a salient pole synchronous machine. Very important points these two are. Okay, and write the meaning of salient pole. I think we have discussed this meaning of salient pole. We might have discussed what is a salient pole. Every question, for every question, the answer is here. Yes, here we have the answer. Salient pole type machine, the term salient means protruding or projecting. I want this answer to be written, right? The term salient means protruding or projecting. Answer. And recall the main parts of a synchronous generator. Main parts of a synchronous generator. What are they? Stator and rotor, isn't it? Stator and rotor. The main parts of a right. These are the of an alternator, a rotor, and a stator. The first statement is giving you this picture, and recall the important parts of a stator and their functions. Important parts of stator and their functions. Yes, that is very important. Important parts of a stator. Yes. Important parts of a stator and their functions. The stator construction, we have many types: stator frame, stator core, stator windings. Stator will be housing all this, right? The stationary part of the machine is called stator. It includes various parts like stator frame, stator core, stator windings, and cooling arrangement also. Right, if it is a huge machine, this cooling arrangement also can be accommodated in the stator. Right, so they are the stator frame. What is the stator frame? It is the outer body of the machine made of cast iron, and it protects the inner parts of the machine. That is the stator frame, outer body of the machine made of cast iron, and it protects the inner parts of the machine. Okay, and here one more question also can be framed here. What is the stator frame made up of? Right, out of which, and what is the function of the stator frame? Right, these are all subtopics. Right, protects the inner parts of the machine. Right, and stator core is made of silicon steel material. And here one more question: what is the stator core made up of? Stator frame is made up of cast iron, but stator core is made up of silicon steel material. So it is made from a number of stamps which are insulated from each other. All stampings are insulated from each other. You know why they are insulated? Its function is to provide an easy path for the magnetic lines of force and accommodate the stator winding. Stator core will accommodate stator winding. Okay, so it is made up of silicon steel material made from a number of stamps that are insulated from each other, and the basic function of the stator core is to provide an easy path for the magnetic lines of force and accommodate the stator winding. Since it is a solid core, right, and the magnetic lines of force, there will not be any air gap between any of these, hence the magnetic lines of force can easily pass through. Right, therefore the magnetic flux density also will be sufficiently enough, which will not have any distractions. Right, and also its function is to accommodate stator winding. And what are stator windings? You have three-phase winding and single-phase winding. Right, slots are cut on the inner periphery of the stator core. You can see that we have inner periphery. You know what is in inner periphery? Periphery is circumference. Yes, you can see here. This is the stator. This portion is this ring is the stator, right? And inner periphery, outer periphery is this one. Inner periphery is inside. So this is the these are the slots, right? Frame. At stator windings, some slots are cut on the inner periphery of the stator core, in which three-phase or single-phase winding is placed. Right, any of the windings can be placed. If it is a single-phase motor or generator, you have this, and three-phase generator, you have this. Then stator windings are made up of copper, enameled copper, and star connection can be used. And the winding is distributed over several slots per phase. The windings per phase can be distributed over several slots, and when the current flows in a distributed winding, it produces an essentially sinusoidal space distribution of EMF. Sinusoidal space distribution of EMF. So this is what recall the important parts of a salient pole rotor and their functions. We have two types of rotors, right? Salient pole and non-salient pole. And the stator and their functions are both same for generator and motor, synchronous generator and synchronous motor. You can call it a synchronous machine. Now, salient pole rotor and their functions, and non-salient pole rotor and their functions. We have these two questions. These are type of questions, and yeah, so this is rotor construction, salient pole rotor, as you can see from the diagram. Right, salient pole rotor, you know salient pole is protruding or projecting, therefore the poles here are clearly visible that they are protruding out from the rotor. Right, the rotating part of the machine is called rotor, you know that. And there are two types of rotor constructions, namely the salient pole and cylindrical. Let us see for salient pole rotor. Right, means projecting, and thus a salient pole rotor consists of poles projecting out from the surface of the rotor core, and this is a view of a 6-pole salient pole rotor. You can see this. This is the structure, and the north and south poles are alternating in nature. They are always alternating in nature. For any machine, for any generator or a motor, you will be having all the poles alternating in nature, north pole and south pole. Right? You can see this. And in this, we can also see a few more names called steel spider, etc. Let us go for that. We'll see those things in detail. First, let us try and understand the rotor once again. Since the rotor is subjected to changing magnetic fields, it is made of steel laminations to reduce eddy current losses. Right, changing magnetic fields and eddy current losses, and poles of identical dimensions are assembled by stacking laminations to the required length. The laminations are stacked together. Stacked together అంటే ఒక కుప్పలాగా పేరుస్తారు అన్నమాట, అన్ని కలిపి ఒకే దగ్గర తీసుకొచ్చి then they will be trying to form the pole. And non-uniform air gap. You know why this is non-uniform air gap? As you can see from the diagram itself, there is air gap between each pole. Here, this is the air gap. This is the air gap. Air gap. Right? A lot of air gaps are there. As you increase the number of poles, the air gaps reduces. Right? Air gaps reduce. And also between the stackings of the laminations, also air gap will be there. And those air gaps also can be reduced if they are closely packed, right? Again, but laminations or whatever we are trying to see are used for eddy current losses, reduce the eddy current losses, right, on the poles. Right, if laminations are stacked together, then you can reduce the eddy current losses. And laminations are steel laminations. Okay, the material used is steel here, and here we will be having a non-uniform air gap, which I have discussed. The air gap is minimized under the pole centers, right? The air gap is minimized under the pole centers. Here at this region, air gap is minimized. See here, this is less air gap, but as you go along, maximum in between the poles. From the poles majhilo, obviously there is more air gap, maximum air gap, and they are constructed for medium and low speeds as they have a large number of poles. We understand that in order to reduce the air gap, we should use more number of poles. When the number of poles increases, then obviously the speeds reduces. Right, hence they can be used for low speeds and medium speeds, around 100 to 400 rpm we can see. And since they are low speeds, there is one more thing, that the size of the machine can be made large. Right, low speed motor kavalante size can be made large, therefore the diameter is increased. When diameter is increased, the axis is reduced here. Right, when diameter oka tire laga untadi annamata, oka tire oka bus lorry tire anta pedda tire untundi kada, atonti tire ela untadi ante axis is small but diameter is big. Right, ala untadi salient pole rotor. Right, has the following important parts. So this rotor has some few more important parts here. One is the spider. The spider is, you can see, this is the spider. This is the spider, right? A steel spider. This is the rotor, right? These are the rotor poles, and in between you have this steel spider. Okay, in between any two poles you can see spider. So it is made up of cast iron, again similar to a stator, to provide an easy path for the magnetic flux, right? As the same thing will be done by the stator also. The stator, we have seen that it is made up of cast iron, and it is used to provide easy path for magnetic flux, because reluctance will be less, because it is a cast iron, solid cast iron material, right? It is keyed to the shaft, right? Keyed to the shaft. What is the meaning of that? See here, this is the shaft. This is the shaft, right? And this is the lock. This rectangle, small rectangular area, this is the lock, right? A shaft ki ఇది lock అయిపోతుంది. So this spider is nothing but the outer periphery of the rotor core. Rotor. To the rotor, we joint. These poles are joined. So it is keyed to the shaft at the outer surface, right? Pole core and pole shoe are also keyed to it. Pole core and pole shoe are also keyed to it. So that is the spider. Now I think we can take one more question here. What is a spider? Right? Define spider, or give the function of a spider, or how is a spider made up of, right? And what is the function of a spider? It is provides easy path for the magnetic flux, and it is how is it designed, and it is keyed to the shaft, and at the outer surface, pole core and pole shoe are keyed to it. Now what is the pole core and pole shoe? It is made of laminated sheet steel material. Pole core provides the least reluctance path for the magnetic field, and pole shoe distributes the field over the whole periphery uniformly to produce a sinusoidal wave. Right, you can see that pole core and pole shoe, right, least reluctance path for any magnetic flux to be generated, reluctance path must be reduced. Similar to our electrical EMF, right, electromotive force, magnetomotive force. Let us try and have some analogy between electromotive force, magnetomotive force, right? Flux and current, reluctance and resistance. We know that in a electrical system, we know that EMF is equal to voltage into EMF is equal to current into resistance. Similarly, for an MMF, we should know that flux into, it is nothing but flux into reluctance. Do you all know these two analogies? Can somebody respond? What happened? Nobody is responding. Am I audible to all of you? Yeah. So, where are we? Yeah, we are discussing about pole cores and pole shoe reluctance path. Right, magnetomotive force is equal to flux into reluctance. Right, and in order to provide, if the reluctance path is less, then this magnetomotive force will be higher, or current will be flux will be higher. Right, similar to if resistance is less, current will be more, isn't it, for a given voltage? So similar to that, if for a given magnetomotive force, flux will be higher when reluctance path is less, and we always want higher magnetic fluxes. Right, that is why we use permanent magnets everywhere while that is in the design of any machine. Okay, so well, let us go to the field winding or exciting winding. It is wound on the former, right? Former is something which is already existing, and there they will be wounding it, right? And ఒక వినాయకుడి విగ్రహం ఎలా తయారు చేస్తారు, you all know that. Already ఒక shape ఉంటుంది, అందులోని these things will be inserted, and the shape will be formed, right? So former is తీసుకొచ్చి, then they will place it over the pole core, right? The field windings or the exciting winding. and field windings ki DC supply is given. Remember, DC supply is given to the field winding, right? Through slip rings. Slip rings vaartaru ikkada. When DC current flows through the field winding, it produces the required magnetic field, right? This is field winding or exciting winding. And damper windings, at the outermost periphery, holes are provided in which copper bars are inserted and short circuited both the sides by rings forming damper winding. Okay, and this damper winding we have already discussed at length about this damper winding. Let me go to question. Recall the advantages of stationary armature that was discussed today itself, right? The advantages of stationary armature. Probably I'm running short of time. I wanted to finish all these things. And how is a damper winding made? We have seen this, right? What are the damper winding made? Yes. Damper windings are made using copper bars which are short circuited at both ends, and they are short circuit coils, and they are placed in the place of the rotor poles of the synchronous machine along the pole axis. Right, and write the equation for synchronous speed and mention the speed in RPM for a 2 4 and 4 pole machine. This we have already for this in the previous class, right? This is the answer for that question. The 2 pole type, when S is equal to 120 into F by P, or F is equal to P into NS by 120, right? And if it is 2 pole 3000 RPM, 4 pole 1500 RPM. Now this is one very important synchronous speed, and the synchronous machine is designed to be running at synchronous speed. You have to remember. Take place, and it will be very difficult, where damper windings will have to play a major role, right? Now, non-salient pole rotor or cylindrical rotor. In this type of rotor, so remember level questions. So many I have framed, and there are many more to be framed, because what is the material used for stator core, right? Stator windings, right? All these things also can be added in this. Since the number of questions has increased, I have stopped writing all those things, because they can be given for multiple objective type questions only. Also. Okay. Now in the understand level, a bit more, the level has increased from the remember level to the understand level. Right. Draw the simple cross-sectional view of a wound rotor synchronous machine, and draw the simple cross-sectional view of a salient pole rotor synchronous machine. This for this I have shown you the answer. Diagram is here. This one. Right. You have to draw this wound rotor and salient pole synchronous machine. The diagrams you have to draw. Right, the main parts are stator and rotor, hence both are here, and stator winding and rotor winding both are here. And you should clearly mention that stator armature, stator is maintained constant, and rotor is producing the field, rotor field, that is, which is rotating, right? And explain the construction of a salient pole alternator by drawing its construction features. Right? Explain the construction of salient pole alternator by drawing its constructional. There may be some typing mistakes, typos here. Constructional spelling has an error, right, in both the words. So explain the construction of salient pole alternator by drawing its constructional features, and explain the construction of non-salient pole alternator by drawing its constructional features. These can be around 6 marks questions. Explanation and draw, then they can go for 8-mark questions. You have and explain the construction. And you can yes, you can draw this diagram. First, here we have the cylindrical rotor or the non-salient. Just draw this diagram. this diagram. If it is asked, it is asked to draw both the diagrams, you can draw these two or yes, and the fifth question, draw the diagram representing the damper winding and its location on the rotor of a synchronous machine. Here we have a lot of, so this is one damper winding, this this diagram you can draw, or this one, or this one. You can draw any of these diagrams, and location of the damper windings also. And explain the purpose of damper winding. Right, explain the purpose of damper winding. Again, we have the explanation. We know when an alternator, the load on the alternator suddenly changes or increases, let us say, then the rotor falls out of synchronism, that is, rotor speed reduces. Right, when rotor rotates at less than synchronous speed, damper winding comes into picture. It is a short circuit coil. It will produce an EMF, and hence the rotor rotates. Right, and the damper winding will create a flux and increase the speed of rotor to catch up with the synchronous speed. So the damper winding always tries to keep the rotor speed at synchronous speed, even during sudden load changes in the alternator, and hunting can be eliminated in the alternator using damper winding, and damper windings help the alternator for smooth running. The questions that I have framed for your for the first topic of our subject, and probably these can be the important questions. I did not go into the apply level. Apply level, we'll see that later stage. Every topic can be given into the apply level. Do you all know this cognitive level of cognitive level, Sama? If somebody can respond, what are the cognitive levels of our teaching learning process which we are discussing? If some sirs have already presented those. Remember level, cognitive levels, and remember level, understand level. There are 4 more levels. Do you all know those?
Sir.
Yeah. What is the next one? Apply level, right? Next one is apply, then it is analyze, then it is evaluate, and then create. So these are the various types of levels which we have. So far I have given only remember level and understand level. Design the questions on apply level also for this topic. Okay, apply level, but since it is a constructional feature only, right, we can go for understand level. So we will not go beyond that level, right? Not level, lower order thinking levels these are. So with this, since this is one, this crossing my mind is, I don't know if you people are really listening to the class, or is it simply going away like that, or because you think that the class is being recorded, we can see this at a later stage or something like that. I don't want that to happen. Probably what I would try to, what I expect from you people is, can you submit the answers for these 2 levels, remember level and understand level, for this topic? You can scan your, scan your answer sheets, and you can take it as an assignment. Scan your answer sheets and send it to me. Can you do that? All of you? What is the time required for this?
Sir, next Monday.
Monday, right? Great. Monday, I told you, Monday I may not be handling class for you. Probably after a 3 o'clock session I can handle, 3 to 3:50 or 4 o'clock I can handle, because morning session my work might be over, because it is a project work and we have only around 5 to 6 batches only. So half an hour per batch, it might take up to 1 o'clock or 2 o'clock. So from 3 o'clock I can handle this lecture on that day if possible. Otherwise I will go for the next day or some other day. I will talk to your faculty. So there are around 10 questions in remember level and 6 questions in understand level. Based on the questions, you write the answers. So you can understand whether it is a 2-mark question or 3-mark questions or 4 marks or 6 or 8 marks. You can take this. Normally, remember level, always we go for 2-mark questions. Majority we will go for 2-mark questions, remember level. And understand level, you can go for simple draw questions or 4-mark questions. And explain and draw, it can go for 8 marks, right? And so third, fourth, fifth questions can go for 8 marks, and the sixth question can go for 4 marks. So 1, 2, and 6 are going for 4 marks, right? The 3, 4, 5 are going for 8 marks, and here all these questions are 2 marks. So you can, and those who will not submit, we'll see what to do with them. Let us see, right? And on the answer, what is this? On the answer sheet which you write, the assignment sheet, on top right corner, you write the roll number, you write the name of the student, name of yours, okay, and scan it properly. Don't use cam scanner, it is being banned. You can go for Adobe Scan in your mobile, and send me that. Right. So promptly, I wish you people will do this, all of you. How many students are